Welcome to the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability, and we'll go over them in a moment. In number 1, we begin the problem with the ideal gas law. PV equals nRT. Now in this problem, we're given 2 separate gases, and in order to put them into my moles, I must find the number of moles of each gas and then add to get the total. Well, these numbers are pretty nice. You have 4 grams of hydrogen, and 1 mole of hydrogen has a mass of 2.0 grams of hydrogen. And I'm sure you could do that one in your head. So that's 2 moles of hydrogen. And then we have 28 grams of nitrogen, and 1 mole of nitrogen has a mass of 28.0 grams of nitrogen. Because when we have these atoms by themselves, they will become diatomic molecules. And then, so I have 1 mole of nitrogen, and when I add them together, I get 3 moles total. Then I'm going to put that into my ideal gas law, and I'm solving the ideal gas law for pressure, and therefore pressure is equal to nRT over V. And I know that I have 3 moles total. And it does not matter which ideal gas constant I use, because whichever one I use, the unit of pressure will come out based on that constant. So first of all, let's use kPa. 8.31 kPa liters per mole Kelvin. And on the very first day, we learned how to determine that R, the ideal gas constant, without memorizing it and using the standard molar volume. And the temperature here is 43 degrees plus 273, and that gives me 316 Kelvin. And then I divide it by my volume that's given in the problem, and it is 5 liters. And then when I do the math, I get 1575.5760. I look back to my original problem, and the number with the least number of significant digits would be 2, and therefore my answer is 1600 kPa. And you'll notice here that my liters cancel, my Kelvin cancels, and my moles cancel, and I'm left with a pressure unit of kPa. Now, had you solved this with the R value for torr, you would come out with 12,000 torr. Or if you had done it in atmospheres, you would come out with 16 atmospheres. And those are the possible answers in different units of pressure depending upon the ideal gas constant that you chose. And that's how you do number 1. In number 2, we are solving for grams. And therefore, when I rearrange my equation, I start with PV equals nRT. Now, you'll recall that N is equal to moles, and moles are gram over molecular weight. I substitute that in, and then I rearrange for the unit that I'm looking for, which is grams, and I must multiply by molecular weight, and then I must divide by RT to get grams. Now I know that this compound is nitrogen, and therefore I can look on any periodic chart and find out what its molecular weight is. And it's 28.0 grams of nitrogen. Grams per mole is molecular weight, is grams per mole. And the pressure that we're given in the problem is 3 atm. And we're given a volume of 2 liters, and I will divide that by the ideal gas constant in atmospheres. Because I have atmospheres, I must use the constant that is in atmospheres. And that would be 0.0821 atmospheres liters per mole Kelvin. And then I have to multiply by the temperature, and that would be 287 Kelvin. Now, you were given degrees Celsius in the problem, and you were given 14 degrees Celsius. So 14 plus 273 will give me my 287. And then when I do the math here, I'm going to get 7.1299. I look back to my original problem and I see I need 2 significant digits, and therefore the 2 does not round the 1 up, and my answer is going to be 7.1 grams of nitrogen. And again, you can see here that my moles cancel, my Kelvin cancels, my liters cancel, and my atmospheres cancel, leaving me grams. And that would be number 2. Now today, what you need to do is go over the answers to worksheet E, and tonight you have worksheet F, and you shouldn't have any problems with that. Just work those problems and you'll do really well on the quiz and the assessment that are upcoming. Well, good luck with that, and I can't wait to see you tomorrow.